WSP Snack and Learn webinar. Today, I am going to talk about asset management in green infrastructure and how to optimize its value. We have placed a copy of the presentation in the handouts box, which you can download. If you have a question, please put it in the questions box, but remember, we will deal with the questions at the end of the presentation. I will start with a little introduction to me and the AM advisory in Canada. Then I will cover what green infrastructure is and what the difference is between green and gray infrastructure. I will then talk about how you value green infrastructure and finish off with a couple of brief case studies. If you don't know me, my name is John. I'm a professional forester and asset manager, and I work with the Infrastructure and Transportation Advisory Service team out of Fredericton, New Brunswick. I started my career on the West Coast in British Columbia, consulting with companies on their forest management planning and GIS. I worked for two consulting companies, one in North Vancouver and the other in Prince George. I then moved to Winnipeg to work with a firm called Lynette Geomatics, where we were developing an ERP for forestry companies called Woodlands the System. I also worked at Wardrop Engineering to lead their GIS department. In 2002, I decided to move to New Brunswick and get a job with the Department of Transportation as a senior systems analyst. I spent the next 10 years working on strategic software implementations and developing the department's award-winning asset management business framework. I was then again drawn to the dark side, consulting that is. Asset management had become a very valuable skill, and I decided to join Opus International, which is now WSP. In Canada, the advisory service team, which is part of the Transportation and Infrastructure group, is made up of 5 service areas: real estate and infrastructure, sustainable transportation, smart mobility, cybersecurity, and of course, asset management. The asset management team, we work with all asset types, and we have corresponding subject matter experts for many of the assets. And I am the subject matter expert for green infrastructure. We also have experts in pavement management, bridges, water, wastewater, buildings, marine, parks, and many others. As with anything, there are many different definitions of green infrastructure. So let's break it down a bit. There are constructed assets. These are engineered solutions that take advantage of natural processes in a design system which is constructed to deliver services. Usually the services are specific, for example, using a reed bed for wastewater treatment or green roofs for heat abatement. Natural capital are whole systems that are providing ecosystem services, as well as some services that would otherwise be delivered by gray infrastructure. Some examples of natural capital are aquifers for potable water, lakes for water storage, wetlands for flood mitigation, etc. And of course, your urban forest, which includes natural areas, parks, and maintained trees. There are probably as many examples of natural capital as there are natural systems. Of course, you can guess that gray infrastructure is that which is constructed and doesn't use natural processes to deliver services. But the services I want to talk about are how you have to approach managing the assets, and then we can talk about valuation. Let's look at the urban forest. Gray assets life cycles begin in its most desirable state, providing the services at the highest level for the design in the best condition. Green assets grow instead of deteriorating. For example, street trees start out obviously as a sapling and grow larger. Services and therefore their value increases with the growth of the tree, and this can be exponential. This requires a very different approach to managing assets. Understanding the systems, i.e. the biological processes involved in the tree and the stand growth, are important, just like understanding deterioration of pavements. This kind of knowledge requires a subject matter expert. Typically, we use some from the client team and some from our WSP team. We have a deep bench of experts of most gray and green infrastructure. Occasionally, we reach out to partners that can help us with local conditions, climate zones, and species behavior. We then use a mathematical optimization model to develop management scenarios. We take into account growth, intervention strategies, mortality, logistics, maintenance, operations, and any other dynamic that the client deems important with supporting data. This gives us the overall management strategy, financial forecasts, and treatment targets for the different types of assets. Let's look at valuing a tree. Valuing a tree is a tricky endeavor, and some of the principles are not widely accepted yet when it comes to non-merchantable values. So let's discuss the options and why you might use each one. Replacement cost is one of the options, but it's not what you think it is. When it comes to trees and stands, as well as other green assets, to estimate replacement cost of a mature asset, you need to use the replacement value of what it would take to replicate the services being provided. Currently, the Public Service Board of Canada doesn't have firm guidance on how to value things like street trees and forest stands, but there are a number of conventions and methodologies that are used and borrowed from other sectors to value the asset portfolio. In the case of street trees, a trunk formula method has been widely used, which basically requires you to value a tree at the cost of replacing the area of the cross-section of the tree at breast height. If you do a little math, you'll see that a very large mature tree could require dozens of saplings to make up the cost of about $1,000 to $1,500 per tree for planting and care in the first 3 years. The resulting values of mature trees can be impressive. This accounts for the value of the services of that tree is providing and the fact that they increase as the tree grows rather than decrease as they age, as they would when you would expect from gray infrastructure. The economic value of a tree asset is similar to how you would value a gray infrastructure when doing a cost benefit. The services that the tree provides can be quantified and valued in dollars. This can be compared to the cost to get an appropriate benefit cost ratio. Remembering, of course, that the trees provide more benefits as they grow. So you have to look at a flow of benefits rather than a snapshot in time. In some cases, the asset may have value as a merchantable commodity. This means, for instance, that a volume of wood harvested from a stand could be sold on the open market and therefore has a corresponding monetary value. Merchantable value mostly comes from the stem of a tree, producing saw logs and wood chips used for pulp and paper manufacturing. Other products can also be produced, such as wood pellets for firewood, veneer logs, etc. Most municipalities wouldn't have this option available to them, but some of our clients have significant woodlands, either in the form of a forest license or in freehold tracts which the municipality owns. Depending on the management goals and objectives for the forest, harvested volume for sale might be a primary or secondary objective. Some silviculture activities, such as thinning, may produce merchantable volume as a byproduct and therefore revenue, so that has to be added into the mix for the cost benefit. Now, I've been talking about services all through this presentation, but I haven't really explained what they are or the principles behind them. Ecosystem services are those which are derived usually in a flow of benefits from the natural systems. There are many services, but they can be classified into 4 main categories. They are provisioning. These are basic need type services, providing water, fuel, and food. Regulating are where a natural system helps control and moderate things like flooding and carbon emissions. And cultural, these services speak to the emotional and spiritual well-being aspects. And then there's a supporting, and these are component services which help with others, such as for basic things like photosynthesis, soil formation, and habitat. As you can see, all of these are very important to us, and there's an increasing awareness of this. There are a number of ways in which we can use both off-the-shelf tools and research to include these values in our analysis based on the client's need and availability of data. There are a number of models based on this approach, but the 4 major categories of services are always represented. You can see how they break down into individual services in this model from the City of Vancouver. Now let's talk a bit about a couple of our case studies. The first one is our 2017 Green Infrastructure Asset Management Plan for York Region in Ontario. This is a large part of Greater Toronto, which includes Mississauga and 8 other municipalities. York Region has highly populated areas, green belt areas, and more rural areas. The region provides services through an urban forest, which at the time had about 50,000 trees, and a regional forest which consisted about 2,300 hectares in about 14 different tracts. So there's a number of key success factors that the client had. They wanted to make green infrastructure part of their larger asset portfolio. They wanted to understand the value of its biological and civil assets associated with the forestry and cultural heritage. They wanted to develop a 100-year financial forecast compliant with their policy and the Ontario regulation. There's since been a new regulation, but the old one was required a financial forecast. It didn't have to be 100 years, but it was a requirement for a forecast. Follow the objectives of the York Management Plan, the Forest Management Plan, specifically to establish natural forest types. And they wanted to plan for contributing to the overall canopy goal for the region and account for risk, both from biological factors and financial factors, and create a continuous improvement plan. This is York Region. This is Toronto, Greater Toronto down here. And you can see they have labeled, there are 14 tracks, and their numbers 33 through 50. And these are what some would call woodlots or small forests, and they're scattered throughout the region. And then they've got a number of trails labeled over here, all with numbers. And those are typically within the tracks, or some of them are adjacent or for some other reason. But their forest is distributed throughout this area, as well as the street trees. The project focused on the urban forest and the regional forest. So the urban forest was mostly street trees, planter boxes, and park trees. The regional forest was the tracks taken in combination. And there was also, as well as the biological aspect, there's the civil infrastructure that was in place to support these green assets, and they were also included in the analysis. Ontario has a very complex planning environment. There's a lot of business drivers that come from externally, both provincially and from other organizations. We set up this diagram to help understand the planning context. There's many higher level plans which influence asset management plans. So you can see that the asset management plan is down in the lower right, but there's many plan strategies and external factors that influence this plan and give it goals and objectives through the vision of the council in York Region. So following OREGs, the Ontario regulations, as well as the best practice in developing an asset management plan, we've developed a state of the infrastructure. This is just an example of one of the asset groups that we examined, and this is for street trees. So you can see there's about 60-some thousand street trees in the inventory, mostly hardwood. They are compiled of a number of different species. They're in different situations and they have different conditions. All of this is detailed and explained in the state of the infrastructure package that we've developed. We also assess the data completeness and accuracy and report that right along with the state of the infrastructure. So this is a similar slide with, but this one is for forest stands. And if you're not familiar with the forestry term stand, it's a group of homogeneous trees, so they're the same age and the same species mix. And this gives a report on how many hectares. You can see it's 2,300 hectares. And there's evaluation, condition ratings, and the data confidence similar to with the street trees. I wanted to show an example of how we go through the finding the next step in the puzzle, which is understanding the assets and their dynamics throughout their life cycle. And we use this tool called a life cycle diagram. And we take an asset and we go over its entire life cycle, and we look at all of the opportunities for intervention, both from a maintenance and capital perspective. And then we detail these out on the diagram to show the complexity and the timing of all of the interventions. Then we take this and we go a lot further and we dissect it, each treatment, and we figure out what the costs are and what the impacts are to either deterioration or growth. And then we take that and we use that as food for our optimization model. So this one just happens to be for street trees for York Region. So the results, I'm not going to show you any numbers, but I'm going to show you just some high-level financial forecasting, I guess, images. And you can see on the left, there's a maintenance one, and on the right, there's a capital one. And the maintenance one shows a dramatic increase. And depending on the scenario you looked at, because there's two scenarios on that graph, the little dotted line is a more moderate scenario. There was an increase that they weren't expecting, and they went away and had to deal with that. But it wasn't coming from their activities, it was coming from an external factor. On the right, you can see that what we've done is we've planned a situation where they can contribute to a reserve. And there's two versions of that, the blue and the black line, and each one lets them accomplish their goals and objectives with all their activities, and it will even out the spending over the planning horizon. So rather than have up and down spending, they can have an even spend. So I'm going a little bit over time, so I think I'll just skip the Edmonton one for now. And if you want to ask questions about that, we can talk about it. You can contact me. But what I did want to say about it is they had a similar situation, but they had a lot more trees and they had a lot more complicated activities that they wanted to include in their asset management plan. So this is a similar This is a similar asset management strategy life cycle diagram for street trees, and they had this is their the amount of complexity that they had in their life cycle. One last thing, we use a number of tools to do the optimization. One of them, the one that we use for Edmonton, was called REMSOFT Spatial Planning System. It's linear programming optimization, and it allows you to develop your own model and include any kinds of activities, choices that you want in it, and forecasts an optimal financial plan over whatever planning horizon that you wish to do. So just some key takeaways before we start answering questions. Green infrastructure assets can be built or natural. Often the natural ones are invisible to people and they are not valued in your financial valuations. The value of green infrastructure, it's not simple, and you have to account for growth and service delivery. Asset management plans can be developed using asset management and forest modeling techniques. Green infrastructure AMP should be done right alongside of the gray infrastructure, and use subject matter experts when developing these plans, such as urban foresters, arborists, ecologists, and landscape architects. And you want somebody with local knowledge that can contribute to understanding the life cycle of each of these kinds of assets. Just want to mention we have a number of other Stack and Learn webinars coming up. You can find this on your handout, and it will tell you when they are, and you can sign up for those. And I want to thank you for your participation. I'm sorry I went a couple minutes long. Now we can answer questions. I'm going to leave this slide up, so if you want to copy down my contact information and ask me anything later on, would encourage that.
Thank you, John, for your presentation. So just a reminder before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform. And also you can download the PDF version of the presentation from the handout box on the dashboard. I will start with the first question. Should the value of green infrastructure be included as assets in financial statements?
Okay, so that's a little tricky because depending on the green asset, if it's a built asset, it's almost certainly already included. So like if it's a storm water abatement system where you have a planter box that captures rainwater, that's probably almost certainly already included. If it's your urban forest, there's probably a very low chance that that's included. The guidance that we're giving right now is that it probably shouldn't be included as a valued asset in your financial statement, but it needs to go in the notes. And this may change quickly over the next few years because I think that's changing.
Thank you. Are parks considered green infrastructure?
Most parks would be because they have their green space. Not everything in a park obviously is green. Usually there's some equipment, or sometimes there's athletic fields or things like tennis courts and that sort of thing. So there's kind of a mix, but mostly yes, I would say they would.
Thank you. Many trees in the cities are on private land. Do you include those in your asset management plan?
They probably don't belong in the asset management plan, but usually the city has a larger strategy that includes a canopy target or a canopy goal. And these can be wildly different depending on the area, but that considers the private land trees, because you don't have a lot of control over the private land depending on where you are. Some municipalities have a tree bylaw which kind of restricts what you can do with trees on private land, but most of that will have to be encouraged through public engagement and education.
Thank you. We have a comment here. I was wondering if you can just let us know your thoughts on this. The comment is like this: for trees in urban areas, there will be additional maintenance costs. Trees for some or more can destroy sidewalks or even building roofs with their roots growth.
Yes, and that, I think that comes down to, there's a couple of things. One, usually the tree has been planted in an area, or maybe it just has grown in an area that wasn't really designed to handle it. So your street standards have to account for the type of trees that you're going to have growing there and their age. So it's better to design in the capacity, and then you won't have that damage in the first place.
Thank you. We still have a few more minutes. I was wondering if you can walk us through the second case study in the minutes that we still have.
Okay, sure. So the city of Edmonton, Alberta, and it has engaged us to do an asset management plan for their urban forest, and this includes all their street trees, which is about 375,000. What they're calling natural areas, which are areas that are largely untouched and undeveloped, and that belong to the city and are managed by the city, and 730 hectares of natural areas, which they intend to increase over time. They wanted a 50-year projection, and they wanted to incorporate risk in that. And they have a complex legislative and strategic planning environments. So not unsimilar to Ontario, but it's different in some ways. So their key success factors were understanding the funding requirements for capital and maintenance. So they have a lot of maintenance, they have a lot of mature trees, so the structural pruning cost is very high, and they have a real need to understand what those future requirements are going to be. They wanted to meet the Edmonton's policy requirements for asset management planning. So all their assets have a similar requirement for having an asset management plan in place. They have a goal that was set to meet 2 million trees planted by 2050. And they wanted to increase those natural areas. So, and the naturalized areas that they have, I'll explain those in a minute. And we also have canopy goals, which include private land, as we were discussing. And they wanted to understand risk. So we did modeling scenarios that included both drought and insect infestation. And of course, we developed a continuous improvement plan for them. So the naturalization, this is not unique to Edmonton, but they approach it in this way. They look at areas that are being mowed currently, and then they go through a process to bring them back to a natural state or a naturalized state, because they want to differentiate between their naturalized areas and their natural areas. So they go through this process to where they stop mowing, they start removing invasive plants and noxious weeds. They assess whether they want to plant it. Then they go through if they plant it, they water those trees and they bring it into a certain density that they want, and then they then they do maintenance on that over the next 5 to 20 years, depending on how it does. And then that process, they're not really sure yet what's going to happen after that, because they haven't been doing this for that long. But I think the goal is to transition those into sort of a natural state. So these are forecasts. We didn't have a lot of time to talk about this before, and they're over a 50-year period. So this is just looking at the number of trees that they have, because they have a planting, they infill plant, they have new developed areas adding to the city all the time. So they're going to have an increased amount of trees. So growth over time and just the amount of trees that they're going to have. And then this is this middle part graph has just the throughout the planting horizon, the different stages that they're in. So whether the tree is a dead state or it's been replanted, or they're going to plant new, that's all represented in this graph. And then down here we have the total of maintained trees, which is similar to this, and then the total value of all the trees in the inventory. So we're talking about billions here of value in the urban forest just for the street trees. We also looked at their pruning requirements. So we know the age distribution of all the trees, so we know when they're going to be required to be pruned, and we know when the city does this kind of pruning. So we embedded this all in the model so that we know what kind of pruning on what kind of trees, how much it's going to cost, and when the high requirements are going to happen, so they can plan to have the right number of crews available and that sort of thing over that 50-year time frame. So that's all I really had plans for to show you for that. Again, if you have any questions later on, and you can feel free to contact me, and I'll be happy to answer them.
Thank you, John. Thank you everyone for joining. You have John's email here, and thank you for participating today. We hope to see you in the additional Stack and Run webinars on asset management.